Okay, let's see example number 1. This is to calculate conditional PDFs. So let random variables x and y have a joint PDF which is uniform over the triangle with vertices at 0, 0, 0, 1, and 1, 0. And we have to find the conditional PDF of x given y. Okay, so to see the joint PDF, it's better to calculate the joint support, and it's given by this triangle here. So we have 0, 0, let's say we have 0, 1 over here, and we have 1, 0 here. So we have that the joint support is given by this triangle here, right? And this is going to be the joint support. Just so here we plot the y-axis. This is the x-axis for the random variable x. Now what we have to do is to calculate this condition x given y in a value x given y, right? The definition for this is, as we saw, is the joint PDF over the marginal. So the first thing we have to do is to calculate the marginal, but to calculate the marginal we need to know what is the joint PDF, because we don't know. I mean, we know it's uniform over the triangle, but we don't know what is the value. So the joint PDF is going to be very similar as we saw in the previous lecture, in lecture 3.4. So we know that the total volume is given I mean, it's a valid joint PDF, so the total volume is equal to 1. And we have that the joint support is given by this triangle. So we have that the formula to calculate the volume of the joint PDF, and we know it's uniform, it's given by the area, I mean the area of the joint support. Let me put it in this way. And since it's uniform, it's times the height, and the height is given by the conditional distribution, and this is equal to 1. And this area is the area of the triangle, this triangle over here. So this area is going to be 1 over 2 times 1 times 1, the height and the width, and the width is 1. So this is somewhat equal to 1. So that means that the joint distribution is equal to 2, right? It's 2 over the joint support, right? That is the triangle, this region here, over the joint support, and 0 in other case. So we already know that is 2. Well, first we need to calculate the marginal. So we're going to do that. The marginal, to calculate the marginal, we have to integrate over, let me see, we have to integrate over the other random variable. So we have to integrate over x. So this integral of the joint PDF is 2. We already know that. And we have to see x is, we have to define the limits of this integral that is for x. So in this joint support, x is moving from this line that is 0 until this line, right? So x is moving from here until here. And this line is the function, is the line y equal to 1 minus x, right? And if we solve for x, this is the line x equal to 1 minus y. So x is moving from 0 until 1 minus y. So those are the limits here, from 0 until 1 minus y. And if we do that integral, it's going to be 2 times 1 minus y, and we have to keep in mind the super, because for y it's going to be between 0 and 1. If we are moving, if x is moving from 0 until 1 minus y, then y is moving from 0 to 1. So this is for y between 0 and 1. And that is the marginal. So we already have the information to calculate the conditional distribution, that is f of x given y. It's going to be the joint distribution that we already know that this is equal to 2 over the marginal, that in this case is 2 times 1 minus y, and this is given by 1 over 1 minus y, and this is 4. We have to keep in mind the support, so this is 4. First we have the super for the marginal, so it's for 0 for y between 0 and 1, and x, remember that to calculate that we had also that x is between 0 and 1 minus y. And actually this is the joint support. Okay, so to calculate the conditional distribution we have to keep in mind the joint super.